Okay, so in this video, what we're going to do is we're going to solve for the reactions at A and B due to applied loads. And this problem is a little bit interesting because we have two concentrated forces, but the forces are on either side of support A. So what that's going to do is it's going to cause a little bit of difference when we some moments here. So I want to show this as an example of what we're going to do. So when we start, our approach is basically to come here and to write our free body diagram, and then apply the equations of equilibrium. So when you draw your free body diagram, one way to look at this is just to basically take this and more or less all we're doing is we're going to copy and paste. But the big thing about a free body diagram that we have to really consider here is that when we draw our free body diagram, we're no longer showing our supports. So these supports go away, and instead what we're doing is we're going to show reactions at that beam. So we're going to have AY, we're going to have AX, we're also going to have BY. So these are our reactions that we're showing in our free body diagram. Otherwise, everything else is pretty much the same. The one thing that we do want to add in for our free body diagram are these coordinate system where we show what our positive sign convention is. Okay, so once we have that, I might move it up just to give myself a little bit more space here. But all that we're going to do is we are going to go and apply those equations of equilibrium, solve this thing, and move on. So let's start. So the easiest one, again, sum of the forces in the x direction equals 0. What do we have? Well, AX, the only force in the x direction, equals 0, so that one's easy. Okay, so that's good. That one's done. Basically, we take all the forces that are going to the right, we add them up. There's only one, so it's 0. All right, let's go to sum of moments equation, because this is where it gets a little bit fun. So if we go to sum of the moments, I'm going to just pick point A. All right, we're going to say, let's say sum of the moments about point A equals 0. So here, what we want to do is we want to look at this, and if we put our pencil on point A here, what's going to happen? Well, we're going to have any force that doesn't pass through point A is going to cause a moment. So this 4 kips is going to cause a moment. This 6 kips is going to cause a moment. BY is going to cause a moment. But AX and AY both pass right through point A. So they're not going to cause a moment about point A. So what do we want to do? We want to look at each of those forces, and we want to write them down because they're going to cause moments. So we're going to have the 4 kips, we're going to have the 6 kips, we're going to have BY. And these forces, again, remember, moment equals a force times the distance. So we wrote down the forces, but now what we need to do is we need to find these distances. So what are the distances? Well, the distance from point A to the 4 kips is just 3 feet. So I'm going to multiply by 3 feet. From 6 kips to point A is 5 feet. So I'll get my 5 feet here, and BY is 5 plus 1 is 6. So here we have 6 feet. Okay, all this needs to equal 0, but now we need to write the signs in. So when I do my signs, one of the ways I think of it is if I put my pencil on point A, and you can just literally do this, pull the paper with in the direction of the 4 kips. Well, what's going to happen is your paper is going to want to rotate this way around point A. Okay, that way is the same way as we're saying our positive sign convention is. So typically what I like to do is anything that causes counterclockwise rotation about the point, right? That 4 kips is going to cause this beam if BY wasn't there and 6 kips wasn't there. This 4 kips is going to cause the beam to rotate in counterclockwise fashion. We say that is positive. So let's go there. Let's write that in. We'll write a positive 4 kips times 3 feet. This one here, it's still going down. Right, 4 kips is going down, 6 kips is going down. But here at 6 kips, if we put our pencil on point A and get rid of the 4 kips, get rid of the BY, the only thing we're looking at is 6 kips now. What's going to happen? It's going to make this beam want to rotate in that direction about point A. That direction is clockwise. So clockwise is opposite of our positive sign convention. So what we're going to do is we're going to make that negative. Okay, so we have 2 forces, they're both going down. One causes a positive rotation about point A, one causes a negative rotation about point A. But basically, we're still looking at this moment as a force times the distance, okay? So let's look at BY. BY, again, if we take our pencil, put it on point A, and rotate this, get rid of the 6 kips or get rid of the 4, we're going to rotate this around point A, and it's going to go in a counterclockwise manner. So counterclockwise is going to be positive. So we get 2 positives, 1 negative, and when we're all said and done, we can go and solve this. So I'm just going to make myself a little bit of room here. 4 times 3 is 12 kip feet, minus 6 times 5 is 30 kip feet, plus BY times 6 feet equals 0. So what do we get? We get 12 kip feet minus 30 kip feet. So I believe that's minus 18 kip feet plus by times 6 feet equals 0. So we can add 18 kip feet to both sides, right? And when we do that, you know, the big thing here is we get by times 6 feet equals, now we get a positive 18 kip feet, and by, when we divide both sides by 6 feet, we're going to get, what's that, 3 kips, okay? So we can ink it, we're good, we got an answer. Okay, but we're not done. We still need to go to sum of the forces in the y direction equals 0. So here we're going to take any force that's in the up direction. We're going to call that positive. Any force in the down direction is going to be negative. So just going left to right, minus 4 kips, force going down, plus ay is going up. And then we have minus 6 kips going down plus by going up. You can do this all the up forces, all the down forces, but I just went left to right. So when we substitute and plug in, we get minus 4 kips plus ay minus 6 kips plus 3 kips equals 0. So what do we end up with? We end up with ay is equal to, well, we put the minus 4 on the other side, we put the minus 6 on the other side, that comes to, what, 10 kips minus 3 kips, so we're going to have 7 kips total. So that's the way you can do it if you have two point loads here on opposite sides of a point. The big thing there is to remember that the difference in signs here, one causes a negative, or I'm sorry, one causes a positive, one causes a negative, but you really have to look and be careful with which way this thing is causing it to rotate and how that corresponds with your positive sign convention. So if that helps, hope it does. So until next time, keep working hard, looking onward and upward. Thanks.